All right, I promised you two more examples. So, example 3. This one says a 200 kilogram cart is initially moving 5.8 meters per second. Okay, so 200 kilograms, initially moving, so V1 initial, 5.8 meters per second. When it collides with the second cart of mass 225 kilograms, so 225 kilograms, initially at rest, so V2I is 0. Not sure if that's clear or not. It doesn't look like it to me, but maybe, there we go. I was going to say, but it might be my eyes. When the carts collide, they lock together. With what velocity do they move off with immediately after the collision? So after they collide, they become somehow attached, and they're going to move off with some v final. That's going to be the same for both of them. Okay, so m1 v1 initial plus m2 v2 initial is equal to m1 v1 final plus m2 v2 final. But the m1 v1 final and the m2 v2 final are really the same thing because they're connected. So you could pull it out and you could write this side as m1 plus m2 just v final. Hopefully that makes sense to you because they're connected now and they have the same final velocity. Right? If we multiply this vf in, we get back this top line. So we've just really factored the vf out because we know it's the same. And on this side, nothing changes. Oh, actually, something does change because this term that I'm writing down goes to 0. It's stationary. So I'm looking for my VF. So all I need to do is divide by my brackets. M1 V1 initial divided by M1 plus M2. So M1 was 200 kilograms. And V1 initial was 5.8 meters per second. And then M1 200 kilograms plus M2 225 kilograms. Okay, so it should not be as math-wise as difficult to punch in your calculator this time, I hope. On the top, 1160 kilogram meters per second. On the bottom, 425 kilograms. The kilograms will cancel out. When you divide, you get 2.7294 meters per second. Works out to be positive, which means it's going in the direction of whatever the first one was originally. And since we weren't told that in the question, we can just put in brackets orig, meaning whatever that original direction was, this one's still going that way. Or these two are still going that way. All right, and example number 4. Example number 4 is going to be one of those collision or explosion ones, except it's not really going to be exploding. It's going to be two figure skaters. Okay, so here they are. The first dude's mass is 50 kilograms, and the second one's mass is 80 kilograms. And they are standing together at the beginning of their program, so this is like a pair skating. As the music begins, they push off each other. If the 80 kilogram skater moves with the speed of 1.5 meters per second east, so this guy is going V2 with the speed of 1.5 meters per second east, and then the question wants to know what's the velocity of the other skaters, so we're looking for V1. Now I purposely didn't put in an F or an I here. Which is this 1.5 meters per second, and which are you looking for V1? Well, what's their initial? It says they're standing together. So V1 initial must be 0 if they're standing, and V2 initial must be 0. And what we're being given here is their final, and you're looking for the final. Okay, so then you write down your equation. M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. This one actually simplifies so that it's quite easy. Because the two V initials are 0, this goes to 0, this goes to 0. And we're looking for V1F. So take your other term over. Negative M2V2F will equal M1V1F. Divide both sides by M1. And by now you know I always pull my unknown out here. So V1F will equal negative M2, negative 80 kilograms. V2F, 1.5 meters per second, divided by M1, 50 kilograms. And when you do this, you get a V1F to be negative 8 over 5, 3, 2.4. 2.4 meters per second. What does this negative mean? It means west, because the other guy was going east, right? So don't put opposite motion if you actually know the direction. So don't say opposite number 2. We know what opposite number 2 it is, west. Up here we couldn't put east or west because we weren't told it. But in this one we were. Okay? Now while I was doing this, I had a thought about this that I was going to say when I got to the end. Oh, I know what it was. I was thinking about if you've ever fired a gun, and hopefully not many of you have, but at least if you've seen someone fire a gun, most of you probably know the gun kicks back. Well, it kicks back because there's no momentum in the beginning, and then one object goes one way, so it has some momentum, the bullet, so the gun has to have momentum equal but opposite that. The bullet is really tiny and has a really high speed. The gun is larger, so the speed it kicks back with is not as big, which is good for the person holding the gun. But if you're holding it against your eye or your shoulder, you might end up with a bruise from the kickback. Okay, so that's example number 4. So tonight, all of your questions are going to be with conservation of momentum, all the different types, just to give you some practice. So they're going to be numbers 6 to 10 on that sheet. Okay.